Guys, if you want to learn AWS or if you want to learn DevOps, so what are the prerequisites? The main prerequisites to attend for the AWS or DevOps is Linux basics, guys. Linux basics. Basic commands of the Linux is very, very important to attend for this AWS or DevOps. Okay, here first we are going to discuss this Linux basics. How many days we are going to spend on this Linux basics? Almost we are going to spend 7 days to discuss this Linux basics, guys. We are going to spend 7 days to discuss this Linux basics. And what is Linux? And what is the difference between Windows and Linux operating system? What Linux commands are there? Right. So to discuss all these things, 7 days we are going to spend on this. Right. After completing this Linux basics, we will discuss shell scripting, guys. Shell scripting. Right. Shell scripting also, right, how much is required for DevOps and AWS, up to that level I am going to cover. Right, to complete this Linux basics and shell scripting basics, right, we are going to spend 10 days, guys. We are going to spend 10 days to finish this Linux basics and shell scripting, guys. Guys, to attend for this AWS or DevOps, anything, guys, these two are the prerequisites, guys. These two are the prerequisites for AWS and DevOps. That's why first we are going to understand Linux and shell scripting. Once it is completed, then I will come to AWS, guys. Then I will come to AWS. Right. So how many services we are going to learn in AWS, guys? 20 plus services. 20 plus services we are going to learn in AWS, guys. What services we are going to learn? Already I have given that list, guys. Let me open that list. Already I have given that list. What are the services which we are going to learn in AWS? See, guys. Right. So today we are going to start Linux and shell scripting, guys. Right. First, we are going to understand what is operating system. What is the difference between Windows and Linux operating system? Linux introduction and Linux setup. We are going to understand Linux commands and shell scripting. So these are the things we are going to discuss in part 2, guys. Once it is completed, we are going to understand AWS Cloud. AWS Cloud, 20 plus services we are going to discuss, guys. Before going to main services, first we will understand what is what. First, we need to understand what is cloud computing. What is cloud computing? Why we need to go for this cloud computing? If you set up the infrastructure on your own premises, what are the problems you need to face? Right? To overcome those problems, only cloud computing came into the picture. Right? How many types of cloud providers are available? Right? What advantages are there with this cloud computing? How cloud providers are providing the services? How many ways cloud providers are providing the services? Through IaaS, PaaS, SaaS. Introduction of AWS, how to create the free tier account in AWS. Right? What are the AWS services we are going to discuss? Those services overview. Right? Regions and availability zones in the AWS. So these are the introduction part. This is the introduction part which we are going to discuss in the AWS cloud. First, we are going to understand what is cloud computing, why we need to go for this cloud computing. If you set up the infrastructure on your own premises, what are the problems we will face? How to overcome those problems? Right? Advantages of cloud computing. Right, here we have several cloud providers are available. Right, AWS cloud is available, Azure is available, GCP is available, IBM cloud is available. Several cloud providers are available. How those cloud providers are providing the services? How many ways those cloud providers are providing the services? 3 ways are there. Infrastructure they are providing, platform they are providing, softwares they are providing. Infrastructure as a service, platform as service, software as service. What is the differences between these 3? We are going to understand. Next, introduction of AWS. Account creation, AWS services overview, regions and availability zones in the AWS. We are going to discuss, guys. Once this part is completed, next we will jump into our actual services. Right, first one is right, we will share it, guys. We will share it. See, guys, first, guys, EC2 service we are going to discuss. EC2. What is the purpose of this EC2, guys? EC2 stands for Elastic Compute Cloud. Guys, it is not Elastic Cloud Compute, it is Elastic Compute Cloud. Elastic Compute Cloud, guys. Right, by using this EC2 service, we can create the virtual machines. Right, which virtual machines we can create? Windows virtual machine we can create, Linux virtual machine we can create, Mac virtual machines we can create. By using EC2, we are going to create the virtual machines, servers, instances. Those virtual machines only we can call as servers. We can call as instances, guys. VMs, instances, servers, everything is same. Right? Those things we are going to create by using EC2 service. EC2 stands for what? Elastic Compute Cloud. Next, AMI, Amazon Mission Image. What is this AMI, guys? Amazon Mission Image. If you want to create any virtual machine, we need some image. We need some template. I want to create one resume. For that, you guys will ask, sir, please share sample resume. You guys will ask at the end of the course, you guys will ask, please share sample resume. Right? I will share the resume. Right? In that resume, right, just some modifications you guys will do and you guys will use that. Here also, right, AMI. To create the virtual machines, we are going to use the AMIs. In this AMIs, you will get the operating systems. Whatever the main required things are there to create the virtual machine, all those things you will get in the AMI. You will take this AMI. On top of this AMI, you will add whatever you require, guys. Right? AMI is the image, right, which we will use to create the virtual machines. Here, AWS is providing some AMIs. We can use those AMIs. And we can create our own custom AMIs also. Based on our requirements, we can create our own AMIs also. That also we are going to understand. How to create the custom AMIs, how to use the right, existing AMIs, everything we are going to understand. If you want to create the virtual machine, right, compulsory AMI must be required. This is one of the prerequisite thing to create the virtual machine. Next, EBS, Elastic Block Storage. Right, this is the storage, guys. Right, here, when you create the virtual machine, we are going to get some storage, guys. That is called as root volume. How much root volume, how much storage you will get? If you are going to create the Linux virtual machine, then you will get 8 GB space you will get as the root volume. If you are going to create the Windows virtual machine, then you will get 30 GB space root volume you will get. Right? See, but those root volumes are not permanent. Whenever you terminate this EC2 instance, automatically that volume also will be terminated. Suppose after my work is finished, I will terminate this EC2 instance. Along with this EC2 instance, the volume which you created, the volume which is created, right, that volume also will be deleted. So if you store any data inside that volume, what will happen? You will lose that data also. You will lose that data also. That's why we can't able to write. It is not recommended to store the data inside the root volume. What is the root volume? When you create the virtual machine, along with that virtual machine, you will get some root volume, guys. You will get some volume that is called as the root volume. For Linux machines, 8 GB root volume you will get. For Windows machines, 30 GB you will get, guys. But it is not recommended to store the data inside the root volume. Why? When you terminate the EC2 instance, along with this EC2 instance, that root volume also will be terminated. You can't able to detach that root volume from the EC2 instance, guys. You can't able to detach that root volume from the EC2 instance. Automatically, it will be deleted along with the virtual machine. Then where we need to store the data? Right? For that, we need to create additional volumes. Additional volumes we need to create. See, we have the pen drives, we have the hard disk, right? Those are the additional storages or not. What we are doing, right? We are attaching that pen drive to our laptop and we are storing the data and we are detaching the pen drive from the laptop. We are attaching the hard disk to laptop, we are storing the data and we are detaching the hard disk from the laptop. Same way, here by using Elastic Block Store, by using EBS, we can create the additional volumes. And we can attach that additional volume to your EC2 instance, and you can store the data inside the additional volume, and you can detach that additional volume from the EC2 instance. Tomorrow, if you terminate that EC2 instance also, no problem, right? Our data is available in the additional volume. Already we detached that additional volume from the instance, right? Our data is available in the volume, additional volume. Right? How much space, right? Up to how much space you can create in the additional volume? 16 TB. 16 TB means 16,000 GB. 16,000 GB you can create the additional volume. Minimum 1 GB, maximum 16 TB you can create, guys. Okay, once you detach that additional volume, same additional volume you can attach to another laptop, another EC2 instance also, and you can copy the data from the volume to that EC2 instance. You can copy like that also you can do. And right, in the EBS only, whatever the additional volume you have created, for that we can create the backup also, that is called as snapshot. We can create the backups also for your volumes, that is called as snapshots, creating the snapshots for the additional volumes. That all those things we are going to understand practically in EBS. Next one is ELB, load balancer. Elastic load balancer means what? Elastic load balancer means what? See here, if I deploy my application in the single server, if I deploy my application in the single server, what will happen? If load is increased, if traffic is increased, my server will take more time to provide the response. Sometimes my server get crash also to provide, right? Because of heavy load, my server get crash also. Simple, guys, right here, right? So 60 years old, right, man is there. Right, I have given 10 kgs weight for that man. Right, he can by walk, guys, by walk he can go from source to destination slowly. Right, suppose if I increase the weight, I have increased the weight up to 25 kgs. Okay, he can manage. 60 years old, he can manage, guys. Okay, I can increase the weight up to 50 kgs. Okay, still he is managing. Right, suppose if I increase the weight suddenly 500 kgs, 500 kgs, guys. He can able to move with that 500 kgs weight from source to destination? No, he can't. He can't, guys. Same way here also. See, 100 requests are coming. Okay, my server can able to handle. Right, 1 lakh requests are coming. Okay, my server can able to handle. Right, 10 lakhs requests are coming. My server may take more time to provide the response. Right, 100 lakhs, 1 crore requests are coming. Right, my server get crash also. That's why in real time, we will deploy the applications in the multiple servers, not in single server. When you deploy the application in the multiple server, how you will distribute the load to all those servers, guys? For that, we are going to use load balancer. Load balancer will distribute the load to all the servers. Right here, we need to attach all those servers with the load balancer. Load balancer will distribute the load to all the servers by using round robin algorithm. Internally, it will use one default algorithm, which is round robin algorithm. By using round robin algorithm, it will distribute the load to all the servers. That's why here we need to create the load balancer, guys. Here we are going to see how to create the load balancer for monolith architecture based applications, how to create the load balancer for microservices architecture based applications also. Both we are going to understand, guys. Next, guys, ASG, auto scaling group. What is this ASG, guys? See here, I have deployed my application in 3 servers, guys. Right, per hour I am getting 1 lakh request. To handle that 1 lakh request, right, 3 servers are enough. 3 servers are enough, guys. Assume per hour I am getting 1 lakh request. To handle that 1 lakh request, 3 servers are sufficient. That's why I have created 3 servers and I have deployed my application in 3 servers. Suddenly, my traffic is increased, guys. Per hour I am getting 2 lakhs request. But here I have only 3 servers. 3 servers can handle up to 1 lakh request only. But the traffic is increased. 2 lakhs request I am getting. How I can handle the 2 lakhs request? Again, I need to market. I need to go to market and I need to purchase the systems. I need to set up the servers. I need to do all the required setup, guys. Right? Okay. Right. So total 6 servers are available. 2 lakhs requests are coming. 6 servers can manage the 2 lakhs request, guys. Next day morning, again, I am getting 1 lakh request only per hour. 1 lakh request only per hour, guys. Right. But here you have set up 3 more servers. To set up those 3 more servers, you have invested a lot of money. You have invested a lot of money and you spent a lot of time, guys. What about that money and that time? Everything is waste. Everything is waste, guys. So if you want to do this thing manually, it is right. You need to spend a lot of money and you need to spend a lot of time also, guys. To avoid that problem, AWS is providing one facility which is called auto scaling group, guys. Auto scaling, right? Based on the traffic, it will increase the number of servers. Based on the traffic, it will decrease the number of servers also. Here, scaling we can do in two ways, guys. One is horizontal scaling. Second one is vertical scaling. Horizontal scaling means what, guys? Vertical scaling means what? Generally, we will use horizontal scaling only. Vertical scaling means in the existing system only. I have one server only. In that existing system only, increasing the power of the resources is called as vertical scaling. In my system, I have 2 GB RAM, right? I'm going to increase the 2 GB RAM as 8 GB. Right, I have 2 CPUs. I'm going to increase as 8 CPUs. Like that, in the existing system only, just to increase the power. Just to increase the power of the resources is called as vertical scaling. But that vertical scaling is not recommended. We need to use horizontal scaling. What is horizontal scaling? Right, increasing the servers. Instead of doing everything in existing system only, creating multiple systems is called as horizontal scaling. Generally, we will follow this horizontal scaling only. Why we are not going with vertical scaling, guys? Right, suppose if you try to increase the power, maybe your systems are old generated systems. Old generation systems, guys. Right, in our old generation system, right, if you try to increase the RAM up to 32 GB, right, or 64 GB or 128 GB, right, that machine can able to handle. That machine can able to, right, so manage that much of resources, guys. If you try to increase the CPUs in that old system only, right, 10 CPUs, it can able to handle. It may not. It may not, guys. That's why vertical scaling is not recommended. We need to go for horizontal scaling only. Here we are going to understand how to work with scaling, scale up, scale down, and everything, guys. Next, Route 53. What is this Route 53, guys? See here, I have deployed the application in one system. I have deployed my application in the server. Whenever I'm saying system, means that system will have the IP address, right? That system will have the IP address. Do you guys know Gmail application, right? Where Gmail application is running, that system IP address? Do you guys know where Facebook application is running, that system IP address? Do you guys know where Amazon application is running, that system's IP address? We don't know. We won't share the IP addresses to the customers. Let's see here. If your application is running in the single system, okay, one IP address only available. But in real time, applications are running in multiple servers, guys, not in single server. I deployed my application in 10 servers, 10 machines. All 10 machines will have 10 different IP addresses. Can I share all 10 IP addresses to the customers? All 10 IP addresses to the customers, can I share? No, I won't share, guys. I won't share. Then what you need to do? Then what you will do? See here, all your servers are connected to load balancer. All your servers are connected to load balancer. And load balancer also will have one URL, guys. DNS URL is available for the load balancer, but it is too lengthy. It is too lengthy, guys. People can't able to remember that much of big URLs. Let me show it once. Here in my system, is there any load balancer? See, guys, here load balancer is available. Load balancer is available, guys. See here, for this load balancer, this is the DNS URL, guys. Here we have the DNS URL for this load balancer, guys. Right, this DNS URL is too lengthy, guys. It is too long, too lengthy, guys. So we can't able to remember this DNS URLs, guys. If you share this DNS URL to the customers, they can't able to remember this. Then what we need to do? We need to map these load balancer with the domain names. Domain names means what? Google.com, Facebook.com, Amazon.com. Like that, we need to purchase one domain name and we need to map the domain name with the load balancer DNS URL. You can map the domain name with the your system IP address. You can map the domain name with the S3 bucket URL. Like that, you can map and you can share the domain name to the public. Whenever they send the request to the domain name, right, the domain name will route that request to this load balancer DNS URL. Load balancer will distribute the load to servers. That mapping we need to do, guys. Right, domain name and DNS URL mapping, domain name and your system IP address mapping, domain name and your S3 bucket URL mapping. That mappings we need to do. For that, we are going to use Route 53 service. By using Route 53, what we are going to do? We are going to do the mappings, guys. Domain name and your application URL, your system IP address, right? Your S3 bucket URL. That mappings we are doing by using Route 53 service. Right? Who draw this one, man? I can't able to clear this here. Is there any option to clear this one? Someone only did these activities. All right, guys. Next, guys, S3. What is S3, guys? Simple storage service. S3 stands for simple storage service. Here, what we are going to do, guys? In the S3, we will create the buckets, guys. In the S3, we will create the buckets. It is unlimited storage, guys. You can store huge data. There is no limit for the data. You can store huge data in the S3. But here, first we need to create the bucket. Inside the bucket, we need to upload the objects. And we are going to upload the objects. We are going to store the objects in the S3 buckets, guys. Okay. Everything we need to store in the form of files and folders only. Right? So once you upload the object in the S3, right, for every object, one unique URL will be generated. By using that URL, we can access the objects. We can access the objects, guys. And here we can do the versioning, we can do the object level lag, we can do the encryptions, right? How to do all these things on the S3 bucket, we will discuss, guys. We can create the S3 bucket policies, everything we can do. How to do all these things, we will discuss in the S3, guys. Next, RDS, Relational Database Service. As a AWS engineer, what we will do, guys? We will create the database. Relational database means what? Structural databases, Oracle database, MySQL databases. All these are the structural databases. We will create these databases in AWS, guys. Whenever you have created the MySQL database, suppose Azure, I'm creating the MySQL database. When you create MySQL database in AWS, you will get endpoint URL, you will get database name, you will get database password, you will get database port number, everything you will get. Right? You need to share all these details to developers, guys. Whatever the details are came, you need to give all these details to developers. What developers will do? Developers will configure those details in the application properties file. They have their own application properties file or YML files. They will configure all these DB details in their application properties file. With that, they will connect to the database through application and they will perform all the CRUD operations, whatever they want in the database, guys. As a AWS engineer, what you need to do? Just you need to create the database and whatever the details you have collected, whatever the properties you have collected, those details you need to share with the development team. They will configure those details in their data, in their application, right, properties file or YML file, and they will connect with the database, guys. Same here, DynamoDB. DynamoDB also what? It is also database, guys. This is NoSQL database. RDS is the SQL database. DynamoDB is the NoSQL database. DynamoDB, MongoDB, all these are the NoSQL databases. Right here, RDS means structure is there. Some proper structure, table, rows and columns are available. In DynamoDB, there is no structure, guys. It is a non-structural database, guys. Right. Here once you created, here what we are doing is, right, in the AWS region wise, right, for each region DynamoDB is available. In that DynamoDB we are going to create the tables, and we will give the table information to the developers. They will use the tables in their application. See, here we are creating the database in the RDS, but here we are going to create the tables in the DynamoDB. DynamoDB itself a database, guys. DynamoDB itself a database. In this DynamoDB database, we are going to create the tables. That the tables information we need to give it to the developers. Okay, right? We'll see, guys. I will show one Spring Boot microservices application, how they will configure this DynamoDB and how they will connect through DynamoDB. What dependencies they need to add in the pom.xml file, right? So at the model class level, what annotations they need to use and everything, I will show, guys. Okay, fine. Next, guys, coming to VPC. This is one of the important service in our AWS, guys. This is one of the important service in our AWS. What is VPC? Virtual Private Cloud. Virtual Private Cloud, guys. It is a large network, guys. Right? We will use VPC to provide the security for our resources. Whatever the resources we are using for our application, we need to provide the security for those resources. For that, we are creating our own network. Our own private network we are going to create by using this VPC, right? AWS will provide one default VPC, but we are not going to use that default VPC. We are going to create our own network, our own private network we are going to create by using VPC. Right, VPC is a large network, guys. In this VPC, right, first we need to create the partitions, guys. Those partitions we will call it as subnets. Subnets, guys. We need to create the subnets, guys. And again, we have two types of subnets: public subnet, private subnet, right? So, and we need to provide the internet connection to your VPC. To provide the internet connection to VPC, we are going to use internet gateway. Internet gateway, guys. Right? Public subnet means what? For which subnet internet connection is available, that is called as the public subnet. For which subnet internet connection is not available, that is called the private subnet. Here, right, so which resources outside people can able to access directly, those resources we need to keep inside the public subnet. Which resources outside people can't able to access, you don't want to give the right access to the outside people, those resources we need to keep in the private subnet, right? So all these things we will discuss, guys. Here we are going to understand what is VPC, what is CIDR block range, what is IP sharing, guys. We need to distribute the IP addresses to the subnets, and what is subnet, what is public subnet, what is private subnet, what is internet gateway, what is route tables, what is NAT gateway, what is VPC peering. All those things we are going to discuss in VPC. We are going to spend 4 days on this VPC only. Right, we are going to spend 4 days, guys. VPC is one of the big concept, guys. We are going to spend 4 days to discuss this VPC, guys. Okay, and I will provide in detail with the diagrams, with the practicals, and I will explain this VPC concept, guys. Okay, right. If you keep VPC in your resume, most of the questions will come on this VPC only. That much important, guys. That much important, guys. This VPC. Okay, fine. Once VPC is completed, right, we are going to understand CloudWatch. What is this CloudWatch? It is a monitoring tool. CloudWatch is a monitoring tool, guys. See here what we are going to do. Right here, whenever our application is running in the instance, whenever our application is running in the servers, we need to monitor those servers. We need to monitor those servers, guys. How those servers are running, how much CPU those servers are utilizing, still how much CPU is free, how much memory that CPU is utilizing, how much memory is available. Everything we need to monitor. To monitor that, we are going to use CloudWatch service. CloudWatch will monitor that everything, guys. Here for this CloudWatch, we need to set the alarm. We need to set the alarm, and for that alarm we need to set the trigger point. See, guys, every day morning 6 o'clock we need to wake up. For that we need to set the alarm, guys. We need to set one trigger point, guys. 6 a.m. morning, 6 a.m. that is the trigger point when alarm should trigger, guys. Right here also, when you set the alarm to the CloudWatch, we need to attach one trigger point, guys, for that alarm. We need to add one trigger point for that alarm. What trigger point I am going to add? Array, if CPU utilization is reached to 50%, right, press the alarm. press the alarm, that trigger point I'm adding. Whenever CPU utilization reaches to 50%, immediately my CloudWatch will trigger the alarm. My CloudWatch will trigger the alarm based on the trigger point. What alarm will do? Alarm will send the notification to SNS topic. We are going to attach SNS also, guys. Simple notification service. Right, alarm will send the notification, will push the notification to SNS topic. Right here, whoever subscribed this SNS topic, SNS will trigger the email to all the subscribers. It will send email to all the subscribers, or it will send message to phone numbers, guys. Like that, we need to set up CloudWatch, SNS topic, everything we need to set up, guys. CloudWatch is a monitoring tool, guys. How it will monitor, right, by using, right, SNS topic and this CloudWatch, we are going to understand it here. Okay, fine. So next one is cloud formation. Cloud formation, guys. See, we will use this cloud formation to create the infrastructure. To create the infrastructure, we will use this cloud formation, guys. See, IAC stands for infrastructure as code. IAC stands for infrastructure as code. Here, infrastructure we can create in two ways, guys. One is through GUI we can create. If you go with the AWS Management Console, through GUI, we can create the infrastructure, or else by using code also, we can create the infrastructure. We need to write the code. To create the infrastructure, we need to write our code, guys. With that code also, we can create the infrastructure. See here, as a IAC, as infrastructure as code, we have two things are available, guys. Right? Either you need to go for Terraform or you need to go for cloud formation. Here, what is the difference between Terraform and cloud formation? If you go with the Terraform, right, it will provide the support for all cloud providers. All cloud providers means what? AWS, Azure, GCP, IBM. Right? Terraform will provide the support for all cloud providers. By using Terraform, you can create the infrastructure in any cloud, guys. But coming to this cloud formation, this is only for AWS. Right? By using cloud formation, you can create the infrastructure only in the AWS, guys. Here, we need to write some code to create the infrastructure. We need to write in the JSON format or YML format, guys. Here we have JSON or YAML format. And in that format, we need to write some code to create the infrastructures. Understood, guys? Infrastructure means what? Right, missions. I want to create some instances. I want to create S3 bucket. I want to create VPC. These are the infrastructures only. To create that infrastructure, instead of going with GUI, I'm going with this IAC, infrastructure as code approach to create the infrastructure, guys. Cloud formation is one of the infrastructure as code service. By using this, we can create the infrastructure, guys. Okay, fine. Next, guys, SQS, guys. Simple queue service. Simple queue service, guys. In the AWS, we are going to create one queue, guys. We will create the queues, guys. And here, through my application, through my microservices, through services, I'm going to send the message to queue. Those messages are stored in the queue, guys. And I will create some subscribers also. Right? Those subscribers will come and will consume the messages from the queue, guys. Until the subscribers are consuming the messages, those messages are available in the queue only. Whenever subscribers are consumed those messages will gone from the queue, guys. Here I will show Spring Boot application with SQS, guys. How to send the messages to queue through Spring Boot application. How to consume the messages from the queue using Spring Boot application. I will show it here, guys. Okay. Next, guys, email services, guys. Here we are going to send the email notifications, guys. How to set up? Right here we need to set up the SMTP servers to send the email notifications. Right, through Java application. Right, we can integrate Java application and this SMTP server to send the email notifications, guys. We will discuss that one at here, guys. Right, SNS, guys. Here just at the time of working with CloudWatch only, I'm going to show this SNS also. Here in the SNS, we need to create the topic. Inside the topic, right here, alarm will push the messages to the topic. It will trigger the emails to the subscribers, guys. How to use the SNS also, we are going to discuss it here. Okay, right, SQS, SES, SNS. After that, ECS, Elastic Container Service. Elastic Container Service. Generally, in the Docker sessions, we will create the Docker images, guys. we will create the Docker images, guys. From the Docker file, we will create the Docker images and we will upload the Docker images in the Docker Hub, guys. Docker Hub is a registry. In the Docker Hub registry, we will upload the images. Later, we will take the Docker image from the Docker Hub and we will start the container. To start the container, we need to run some commands, guys. Docker run command, we need to execute to start the container, and we need to add some attributes, guys. Detached mode attribute and port mappings, all those things we need to do, guys. Okay, if you want to start the container, first you need to create one EC2 instance and you need to install the Docker in that instance. Then only you can able to pull the image from the Docker Hub and you can run the container. See, guys, observe carefully. Guys, observe carefully. See here, if you want to start the container, first you need to create one EC2 instance and you need to install the Docker and you need to pull the Docker image, you need to pull from the Docker Hub and you need to run the Docker run command. Docker run command you need to run. Right, while running this Docker run command, we need to add multiple options like detached mode and port mapping, everything we need to add it here, guys. See, so these many activities we need to do. If you write here, first you need to create one virtual machine and you need to install the Docker software. You need to pull the Docker images from the Docker Hub. Then only you can able to run the Docker image. When you run the Docker image, container will be created. Inside the container, our application is running. Okay. Oh, these many activities we need to do. No, I can't able to do these many activities. Because I have the Docker image. Right. Just run the Docker container. Just to create the Docker container, I can't able to create the EC2 instance. I can't able to install the Docker software. Nothing I want to do. Nothing I want to do, guys. I have the Docker image. Can you run the container? Can you run the container by using that Docker image? Yes. AWS is providing one service. If you have the Docker image, give the Docker image to AWS by using ECS, Elastic Container Service. Elastic Container Service, it will run the container. It will run the container. We no need to create the EC2 instance. We no need to install the Docker software. Nothing you need to do. If you have the Docker image, give that image to ECS. ECS will run the container for you. Understand how to work with ECS and all those things? We will understand it here, guys. Next, guys, ECS stands for Elastic Container Service. Inside that container only, our application is running, guys. Next one, guys, EKS, Elastic Kubernetes Service. Elastic Kubernetes Service, guys. See, guys, when you are going to work with Kubernetes, in the Kubernetes cluster, we are going to deploy our applications. In the Kubernetes cluster, we are going to deploy our applications, guys. Here generally, if you want, you can create self-managed cluster also. Self-managed clusters, we can create in two ways. Either by using Minikube, you can create, or by using Kubedium. Right, Kubedium, you can create, guys. Right, Minikube or Kubedium. By using Kubedium or Minikube, you can create the self-managed cluster, guys. If you want to create single node cluster, then we need to go for Minikube. If you want to create multi-node cluster, then we need to go for Kubedium. But if you want to create the self-managed cluster, you need to remember lot of commands, guys. At least 40 to 50 commands you need to execute to create the self-managed cluster. You need to remember lot of commands, guys. And when you are going to work with the self-managed cluster, if there is any problem with the control plane, if there is any problem with the master node, you only need to take care. That is created by you only. So if there is any problem, you are only the responsible person to correct those things, guys. Right? You only need to take care everything. This is the self-managed cluster. Everything is created by you only. So you only need to take care everything in the self-managed cluster. No. I can't able to remember. I can't able to remember these many number of commands. I can't able to manage the self cluster, guys. I can't able to manage the cluster if there is any problem. No problem. AWS is providing one service, EKS, Elastic Kubernetes Service. Elastic Kubernetes Service AWS is providing. You can use this service to deploy your applications. You can use this service to deploy your applications. You no need to create the self-managed clusters here. You no need to create the self-managed clusters. And here AWS is providing EKS. You can use this EKS service to deploy your applications. But here guys, whoever going to attend for the DevOps sessions, in the DevOps we are going to understand Kubernetes. There we are going to understand both guys. How to work with self-managed clusters, how to work with EKS, both we are going to discuss in the DevOps guys. But coming to AWS, only I will discuss EKS guys. Whoever attending for only AWS service, only EKS I'm going to discuss it here. How to work with EKS, I'm going to cover it here guys. EKS is what guys? Elastic Kubernetes service, which we will use to deploy our applications. In the cluster only, in the Kubernetes cluster only, our application is running guys. Okay, fine. Next guys, after EKS, IAM, right? This IAM AWS in the middle only I will discuss guys. IAM means what guys? Identity and access management. See, when we are going to create the account in the AWS, by default, that is the root account guys. When we are going to create account in the AWS, by default, that is the root account guys. As a root account user, you can access all the services which are available in the AWS. AWS is providing around 300 plus services. So you can access all those services as a root user. But all the services are free guys? No, all the services are not free. All the services are not free. In that, some of the services are paid services are there. Paid services are there. In the company will have the root account. With the company name, they will create the root account. But they won't share that root account details to the employees. Why guys? Right, you are the DevOps engineer guys. You are the Java guy. You are the development guy guys. You don't know how to create the infrastructures and all, but unnecessarily you are trying to use those infrastructure related services guys. What will happen? Unnecessarily bill will generate guys. Unnecessarily bill will generate for the company. That's why they won't give the root user access to all the employees. What they will do? They will create the IAM users. They will create the IAM users. In this IAM user, they will provide the policies. As a developer, what services you can able to access. As a DevOps engineer, what services you can able to access. As a tester, what your services you can able to access. As a fresher, what services you can able to access. As an experienced person, what services you can access. Those policies they will provide, they will add to the IAM users guys. Identity and access management. Here, how they will do in the companies, they will create the groups guys. Development group, DevOps group, testing group, like that they will create groups in the IAM guys. And suppose tomorrow, if any new developer joined, right, they will add that developer to the development group. Already for the development group, they have attached the policies. Whatever the policies are attached to the development group, all those policies will be applicable for the newly joined developer also. Any DevOps engineer joined, they will add the DevOps person in the DevOps group. For the DevOps group, already they have attached some policies. Those policies are applicable for newly joined DevOps engineer also. Like that, they will create the IAM users, IAM groups. They will add the users to the group. They will attach the policies. They can customize the policies. Here I'm going to understand. We are going to understand how to create the custom policies. Right? AWS is providing some policies. But I don't want to use those policies. I want to create my own custom policy. We can create custom policies also. How to create the custom policies, how to attach those custom policies to the users, and how to attach those custom policies to the group. Everything we are going to understand it here. Next, AWS CLI. See guys, infrastructures that we are creating through GUI guys. Infrastructure we can create through GUI, AWS Management Console. At the same time, infrastructure you can create from AWS command line interface also. CLI stands for command line interface. You can access the AWS resources from CLI and you can create the infrastructure from CLI also. You can create the EC2 instance from command line and you can access that EC2 instance from command line. You can create the S3 bucket from command line and you can access the S3 bucket from command line. See guys, whatever the activities we are doing right in the AWS Management Console, everything we can do from the command line interface also. From the command line, first we need to connect to the AWS Management Console and we are going to perform all the activities from the command line interface only. Next guys, after that, Elastic Beanstalk guys. What is this Elastic Beanstalk? Right here, just now I told guys, here I told at the beginning, I have given, right, cloud providers are providing the services in three ways: IaaS, PaaS, SaaS guys. Elastic Beanstalk is one of the platform as a service. Elastic Beanstalk is one of the platform as service. Fine guys, I have developed one application. I want to run my application guys. If you want to run your application, first you should have the proper infrastructure. First you should have the platform to run your application. Right? For that, you need to create the platform. No, I don't have that much of time. I'm very busy with coding. Right? I need to put more focus on the coding. I don't have the time to create the infrastructure. I don't have the time to create the right platform environment and all guys. Right? I need to spend the time to develop the code. I need to spend the time to think about the logics and all guys. Then what I need to do? No problem. You can continue with your coding. Once the development is completed, give your application to Elastic Beanstalk. Give your application. AWS is providing one service which is called Elastic Beanstalk. Once your application development is completed, give your application to Elastic Beanstalk. What this Elastic Beanstalk will do? Elastic Beanstalk will create the platform which is required to run your application. I have given Python application. Elastic Beanstalk will create the right platform which is required to run the Python application. I have given Java application. Elastic Beanstalk will create the platform to run the Java application. I have given Ruby application. Elastic Beanstalk will create the platform to run the Ruby application. Based on your application, right, which platform is required to run your application, Elastic Beanstalk only will create that platform, and it will run your application in that platform. You no need to create any platform, any infrastructure. Just focus on the coding and give that application to Beanstalk. Beanstalk only will create the required platform to run your application. Okay. Next, guys. After that, serverless computing. What is serverless computing, guys? Right. Serverless computing means these servers are managing by the AWS only. Serverless means, right? Serverless means it is not means like there is no server, guys. Without server, we can't able to run the application. Server is there, but we no need to manage that server. That server is managed by the AWS only. Elastic Beanstalk also, so right, AWS managing, guys. In the Elastic Beanstalk also, server is managing by the AWS only. Then what is the difference between these two? What is the difference between these two? Here, Elastic Beanstalk follows pay as you go approach, pay as you go model, guys. Pay as you go model. Here we have two types of models. Pay as you go, pay as use model. Pay as you go model, pay as use model, guys. See, guys. Here we have two models are there, guys. What two models are there? Pay as you go model. Next one is pay as use model. Pay as use model, guys. Elastic Beanstalk will follows pay as you go. Pay as you go, guys. Right? Serverless computing follows pay as use model, guys. What is the difference between these two? What is the difference between these two, guys? In interview, if you said serverless computing means server will be managed by the AWS only, then immediately they will ask, what about Elastic Beanstalk? Who will manage the Elastic Beanstalk servers? AWS only. Then what is the difference between these two? You need to tell Elastic Beanstalk follows pay as you go approach. Right? Serverless computing follows pay as use approach. Immediately they will ask, what is the difference between these two? What is the difference between these two? See, guys, pay as you go means, see, guys, today morning I have deployed my application, guys. Today morning I have deployed my application in the server, guys. Right? See here. You deployed the application today morning, guys, right? But my application is not that much popular. I am not getting any request, guys. In complete day, I haven't received one request also. My application haven't received one request also, guys, in entire day. That still you need to pay the money. Still you need to pay the money, right? Until which time your application is running in the server, till that time you need to pay the money. From deployment to till how much time your application is running in the server, till that time you need to pay the money, whether requests are coming or not, whether you are accessing that application or not. It won't think about that. Your application running means you need to pay the money. That is called pay as you go approach. Pay as use means serverless computing. Means what, guys? Right, my application deployed in the server, but only two requests only came, guys. When your application is accessible, guys, whenever request came, at that time only your application will execute. Even if you deploy the application in the server, right, entire day, right, complete day, your application won't execute, guys. Whenever request came to your application, then only your application will execute, guys. Here in a day, two times requests are came, guys. Two times only my application is executed. Just pay for that time. How much time your application is executed, how much time your application is running, just pay for that time only. You don't need to pay for entire day if you go with the pay as use approach. How much time your application is executing, till that time only you need to pay the money. How much time your application is running in the server, how much time your application is available in the server, till that time you need to pay the money if you go with the pay as you go approach. This is the difference between pay as you go and pay as use approach. Right here we can achieve this right serverless computing by using lambdas, guys. Here we are going to understand how to create the lambda function for Java application, how to create the lambda function for Python application. Everything we are going to understand in the serverless computing lambdas, guys. Okay, here just let me add lambdas. Again, people are asking, sir, you are not going to cover lambdas. Here I am covering this. Serverless computing means lambdas only we are going to discuss. Okay, fine, guys. So these are the minimum services which I am going to discuss. If I miss anything, and if I feel anything is required, definitely I will add at the end, guys. These are the minimum services which I am going to discuss in the AWS. Finally, I will discuss about some of the billing information, which services are paid things, which services are non-paid things, and right, for instances, if a bill got generated, how to send the request to them to waive off that bill. All those things we will discuss in the billing information section, guys. Is it clear, guys? This is the course content of the AWS, guys. Today we are going to start our AWS. That's why first I have given the AWS course content, guys. Right? If you want attend for this AWS sessions, what are the prerequisites, guys? Linux basics are mandatory. Shell scripting basics are mandatory. That's why first we are going to discuss Linux basics and shell scripting basics. Once Linux basic, shell scripting basic is completed, then I will come to this AWS services. We are going to discuss 20 plus services. Around we are going to spend 40 days on this AWS cloud, guys. We are going to spend almost 30 to 40 days on this AWS cloud, guys. Daily 1.5 hour session, 9 to 10:30 I will take the session, guys. Daily 9 a.m. to 10:30 I will take the session. Daily 1.5 hour session, guys. Okay, Monday to Saturday we have the sessions, guys. Monday to Saturday daily 1.5 hour session. Daily class notes I will share, guys. See here how I have prepared the notes, guys. Same way I will prepare the notes for every service. Right in front of you guys only I will type, guys. I'm not going to download from anywhere, guys. I'm not going to download from any website. Notes I will prepare in front of you guys only. At the time of explaining only, I will prepare the notes also for you guys. I'm going to do multitasking, guys. Multitasking, explaining and preparing the notes. Multitasking I will do, guys. Okay. That easy format, understandable way I will prepare the notes for you guys. You guys not required to take any running notes. Just concentrate on the subject, guys. What I'm explaining, notes I will share. I will share the notes. And I will write the notes for you guys and I will share the notes. You guys not required to write any running notes, guys. Tomorrow I'm going to start Linux directly. Fine, guys. Thank you, guys. We will connect tomorrow. Thank you, guys. Thanks for joining, guys. Thank you.